hopefully this will be fun. For everybody that has taken quantum mechanics, that's sort of going to be a review, but that will give you an insight of where all of this craziness started. And for those of you who have not yet taken quantum mechanics and plan to do it next year, next year, this is going to be amazing because that will give you a thumbs up. So do you remember what we were doing last time?
Yes.
What were we doing?
Collision.
Good. So Zain went and hit Amanda, right? And we talked about the center of mass versus the lab frame. You guys all were in the, and those two were in the center of mass. Got it? So the people who are actually participating in the collisions are in the center of mass frame, and you guys, all spectators, are in the lab frame. Right. Okay. So now we are going to talk about scattering. And I'm going to use some really weird words that people in quantum mechanics have heard. Have you heard scattering cross sections?
Yes.
Have you heard differential cross sections?
Yes.
And were they very scary?
Yes.
Good. They are not. And we are going to prove why they are not. When do you remember using them?
Asking a question about what cross section are.
Okay, so if you have not heard differential cross sections, we're going to develop it. And it seems very scary when you first see it in quantum mechanics. And the reason why it seems scary is because you're doing a lot of math. Now we're going to try to do little math, but explain the concept. I mean, we're still going to do math. Don't get me wrong. We're still going to do math. Okay, so what is a cross section? I'm going to try to define a cross section. A cross section, simply put, is the bullseye that the colliding particle sees. Make sense? So for example, in that situation where Zain was going and hitting Amanda, sorry, you didn't see that, but just imagine one person going and hitting another person. The area that he saw that he could hit is called a cross section. That's it, simply put. Good? Now let's put some fancy words on top of this. So what is a cross section? A cross section is the effective area that quantifies the essential likelihood of a scattering event when a beam is incident on a target. So now all of these fancy words mean stuff. The first important thing is this word. Think of it as a bullseye, right? When you aim at a bullseye with a arrow, it's how big that is. The bigger it is, the larger the likelihood that you will hit it. The smaller it is, the less likelihood that you will hit it. Okay? The next important word is a scattering event. Can anyone guess what a scattering event could be?
Two particles colliding.
Perfect. Two particles colliding is a scattering event. The third important word is beam. What is a beam? So when you do particle physics experiments, or when you do solar winds, or when you do astronomy, do you ever have a single particle? Can you ever isolate a single electron? Can you ever isolate a single positron? You never can. What you do is you put a bunch of them together and call it a beam. Okay? And the way you do that,
Write that out.
what?
Want to write that on the notes so we can.
No, I'm going to talk about it.
Okay, good.
So we'll talk about it. Let me just explain this, and then we'll continue with the conversation. We'll do this over and over again. Don't worry. So a beam is a bunch of initial particles that are ejected from whatever source you have. So for example, if sun is your source, what does the sun eject? Photons, electromagnetic radiation, right? And what is the target? So they don't do one photon, right? The sun never ejects one photon. It is always a beam, all directions, right? And then what would be the target in that case?
I guess the honestly, you're an observer on it.
Earth could be a target,
Anything.
anything. Mostly when they were studying this, there are dust particles that are scattered all over the universe, and they call them the targets. And that's when this first study started. So when you have it's called a stellar wind, and a stellar wind particles are coming, ejected, and they hit what are called dust particles in the atmosphere, they get what is known as scattered. Good? So scattering could happen when they are scattered this way, or it could happen when they are scattered that way, or they could also be scattered backwards. And all of these are called different kinds of scattering. Most of the particles in the beam will miss the target. Think about the words I'm using. Most of the particles in the beam will miss the target. There will be only a few particles that actually collide with the target, and that's what we want to study. So imagine if there's like a million, there are like a million particles in the beam, and they come and hit it. How many actually interact? 10? 20? Depends on the size of the target, depends on whether the target is at rest or the target itself is moving. All of these things. So the most important thing that when you talk about collisions is you want to figure out the likelihood of the scattering event to happen. See me using the same words again, but now these words are making sense. So we want to do the likelihood that an event happens. And that is called a cross-section. So it's not scary. Okay? It's actually quite simple.